National Electrical Code Section 310.15b2 applies to both alternating current and direct current circuits. The adjustment factors outlined in this section are designed to compensate for the increased heating that can occur within conductors. This heating can arise from phenomena like the skin effect and the proximity effect. The skin effect is the tendency for alternating current to concentrate its flow towards the outer surface of a conductor. This constrictive flow path effectively reduces the conductor's cross-sectional area, leading to increased resistance and, consequently, greater heat generation. The proximity effect describes the interaction between alternating currents flowing in closely spaced conductors. These currents can induce eddy currents in neighboring conductors, further contributing to heat buildup. It is important to understand that even though direct current circuits lack inductance, they are not immune to heating effects. While the classical skin effect is primarily associated with alternating current, variations in current density across a direct current conductor's cross-section can still occur, particularly in larger conductors or under conditions of rapidly changing direct current. Similarly, the proximity of other conductors, even in a direct current circuit, can influence the current distribution and contribute to uneven heating. Therefore, to ensure the safe and reliable operation of electrical systems, the adjustment factors specified in National Electrical Code Section 310.15b2 should be applied to both direct current and alternating current circuits. This ensures that conductor ampacity is appropriately derated to account for the potential for increased heating, preventing premature insulation degradation and potential fire hazards. Understanding conductor ampacity and its adjustment factors is crucial for electrical safety. Conductors have a maximum current they can carry safely, known as their ampacity. This ampacity is determined by factors like conductor material size, insulation type, and ambient temperature. However, when conductors are installed in certain conditions, their ampacity needs to be adjusted or derated to prevent overheating. One such condition is when multiple current-carrying conductors are bundled together or placed in close proximity. The heat generated by each conductor can raise the overall temperature, reducing the ability of the conductors to dissipate heat. National Electrical Code Section 310.15b2 provides adjustment factors for these situations. These factors are applied to the conductor's base ampacity to determine the allowable ampacity under the specific installation conditions. Another factor affecting conductor ampacity is ambient temperature. Conductors are typically rated for a specific ambient temperature, such as 30 degrees Celsius or 86 degrees Fahrenheit. If the actual ambient temperature exceeds the rated temperature, the conductor's ampacity must be derated. National Electrical Code Section 310.15b16 and 310.15b17 provide ampacity tables and correction factors for different insulation types and ambient temperatures. When applying ampacity adjustment and correction factors, it's important to follow a systematic approach. Firstly, determine the base ampacity of the conductor based on its size, material, and insulation type. Secondly, identify any applicable adjustment factors due to the number of current-carrying conductors or other conditions. Thirdly, determine the ambient temperature correction factor based on the actual ambient temperature and the conductor's insulation type. Fourthly, multiply the base ampacity by all applicable adjustment and correction factors to determine the final allowable ampacity. It's also crucial to consider any voltage drop limitations. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. National Electrical Code Section 210.19a1 provides guidelines for voltage drop in branch circuits, while Section 215.2a3 provides guidelines for voltage drop in feeder circuits. When selecting conductors, it's essential to choose a size that minimizes voltage drop while still meeting the ampacity requirements. In summary, National Electrical Code Section 310.15b2 applies to both alternating current and direct current circuits, and the adjustment factors are intended to account for the increased heating that could occur in conductors due to the skin effect and proximity effect, ensuring electrical safety and reliable operation. The skin effect causes alternating current to flow primarily on the outer surface of a conductor, leading to increased heating. The proximity effect causes alternating current flowing in adjacent conductors to interact, also increasing heating. Although direct current circuits lack inductance, they can still experience heating due to these effects, necessitating the application of adjustment factors from National Electrical Code Section 310.15b2.